All right, so we are doing intro to logs today, so I'm going to start by showing you a little video about logs.
How does the difference between 0.00000000398 and 0.00000000398 cause one to have red eyes after swimming? To answer this, we first need a way of dealing with rather small numbers, or in some cases extremely large numbers. This leads us to the concept of logarithms. Well, what are logarithms? Let's take the base number b and raise it to a power p, like 2 to the third power, and have it equal a number n. We get an exponential equation, b raised to the p power equals n. In our example, that'd be 2 raised to the third power equals 8. The exponent p is said to be the logarithm of the number n. Most of the time, this will be written log base b of the number equals p to the power. This is starting to sound a bit confusing with all the variables. So let's show this with an example. What is the value of log base 10 of 10,000? The same question could be asked using exponents. 10 raised to what power is 10,000? Well, 10 to the fourth is 10,000. So log base 10 of 10,000 must equal 4. This example can also be completed very simply on a scientific calculator. Log base 10 is used so frequently in the sciences that it has the honor of having its own button on most calculators. If the calculator will figure out logs for me, why study them? Just a quick reminder, the log button only computes logarithms of base 10. What if you want to go into computer science and need to understand base 2? So what is log base 2 of 64? In other words, 2 raised to what power is 64? Well, use your fingers. 2, 4, 8, 16, 32, 64. So log base 2 of 64 must equal 6. So what does this have to do with my eyes turning red in some swimming pools and not others? Well, it leads us into an interesting use of logarithms in chemistry. Finding the pH of water samples. pH tells us how acidic or basic a sample is and can be calculated with the formula pH equals negative log base 10 of the hydrogen ion concentration, or H+. We can find the pH of water samples with hydrogen ion concentration of 0.00000000398 and 0.00000000398 quickly on a calculator. Punch negative log of each of those numbers, and you'll see the pHs are 7.4 and 8.4. Since the tears in our eyes have a pH of about 7.4, the H+ concentration of 0.70398 will feel nice on your eyes, but the pH of 8.4 will make you feel itchy and red. It's easy to remember logarithms. Log base b of some number n equals p by repeating the base raised to what power equals the number. The base raised to what power equals the number. The base raised to what power equals the number. So now we know logarithms are very powerful when dealing with extremely small or large numbers. Logarithms can even be used instead of eye drops after swimming.
Okay, so that is the gist of it on logs. Logs are not brand new to you, so hopefully that helped just a little bit about why we need them and what they could be used for. So some really big numbers or really small numbers, but we have to know how to manipulate them. You have to be able to manipulate them with a calculator and without a calculator. Both of those processes are important for you. Okay, so first thing is, what is a logarithm? Well, a logarithm or a log is another way of writing exponents. So if I have this right here, this is log base b of a equals x. The base of the log is also the base of the exponent, so we can write it in exponential form. The base b here becomes the base of the exponential, and so it's b to the x power equals a. Goes around a little circle like that. Okay. So b to the x power equals a, or log base b of a equals x. Same thing works either way. So the common log, a logarithm with base 10 is called a common logarithm and can be written without a base. So this is log base 10 of x. This right here is also log base 10 of x. You just don't have to put the 10. So we are going to write these in exponential form, just rewriting the logs. So log base 7 of 49 equals 2. So the base of the log is the base of the exponent, so it'd be 7 to the what? Second power equals 49. For number 2, what's my base? 2. So 2 to the 5th equals 32. What's the base on number 3? 10. 10 to the 3rd equals 1,000. What about number 4? What's the base? 4. So it'd be 4 to the negative 3rd equals 1 over 64. 5, we'd get 8 to the 1/3 equals 2. 6, 9 to the 3/2 equals 27. Okay? Piece of cake, right? Total review, piece of cake. All right, so now let's do it the other way. Let's take the exponential, write it in the logarithmic form. So the base of the exponential is the base of the log. So this would be log base, what? 5 of what? 25 equals 2. Then here I'd have log base what? 8 of 1 equals 0. Okay, y'all do 9 through 12. Oh, wow, that's loud. Okay. Whew. Everybody awake now? All right, Fernando, what'd you get for number 9? To the power of 1 over 81? So it's just log base 3 of 1 over 8. Okay. Equals what? Negative 4. Okay, good job. All right. So then the next one, George, give me number 10. Okay. Uh-huh. Okay, good. Y'all agree with that? Yes. All right. Thank you very much. All right. Lizbeth. She's not here. All right, Amber. Give me number 11. Okay, let's say that again. Okay. Log of 1/10. Make sure, because I heard like times or something else in there too. So just be careful because it's not multiplication. I want to make sure y'all understand that. Because I know sometimes y'all know how to work them, you can work them, but you don't really know how to read them or like what's happening. So you're taking the log of 1/10 and that gives you -1. Okay, make sense? Awesome job. Thank you. All right, number 12. Michael. What'd you get? Okay, very good. Thank you. All right, we all agree with those? We good? Awesome. All right, so those are just rewriting. Now we want to evaluate. In last period, somebody said, I don't know what it means when it says evaluate. Evaluate basically means like, give me an answer. Okay, got to give me an answer. But there's not even an equation. On the other ones, there were no variables. There's no variables here either, but there's also not an equation. And it says use your knowledge of exponents. So this is equal to, we'll call it x because we're looking for x, right? So the first thing I'm going to do is rewrite it as an exponential. So this will give me 6 to the x power equals 36. Then I'm going to find common bases. What's my common base? 6. So I can say 6 to the x power equals 6 to the what? To the second power. Good. So 6 to the x equals 6 to the second. So x equals what? 2. There's your answer. Yes, you have to write it out. That shows where it came from and that you didn't type buttons on a calculator. All right, so this is going to be 2 to the x power equals 128. So what's your common base here? 2. So 2 to the x power equals 2 to the what? 6th? Yes, y'all agree with that? 2 times 2 is 4, 8, 16, 32, 64. Y'all were just all going to agree with him because you didn't want to have to think. All right, so x equals 7. Everybody okay with that? Yes. All right, so here, what's the base? 10. So 10 to the x power equals 1 over 100. What is your base going to be? I would make my base 10, but that's just me. Yeah. The base is 10. My question was, what is the base? The base is 10. Okay, so 10 to the x equals 10 to the what? Negative 2. Good, because you got to have a negative to get the reciprocal, and then 2, so x equals negative 2. There you go. All right, y'all do 16, 17, and 18. Y'all struggling with 16 a little bit? No. No. Okay. Did you got 3 of them done? Okay. Figure out what your common base is. All right, on 16, what would our common base be? 2. So this would give me, so the 2 is just 2 to the first, right? And then this is going to be 2 to the something times x, 4. This would be 2 to the 4 times x power, because 2 to the 4th is 16. So now 2 to the 4x equals 2 to the first, so 4x equals 1, and x equals what? 1/4, because 2 is the 4th root of 16. There you go. Okay. All right, so 17, Linda. So if we make 3 our common base, we 3 to the x equals 3 to the what? I'm sorry, what? On 17. My common base is 3. 3 to the x equals 3 to the what? Negative what? Negative 3. So x equals negative 3. Y'all agree with that? Yes? Okay, thank you. All right, so then Parker, if I make my common base 8, 8 to the x has to equal 8 to the what? To the 0 power, right? Still got to get a common base, and then x equals 0. Well, it's either got, I mean, it could be 2 if I wanted to make it 2. That works also, but I can't make it 1, because 1 to any power is still going to give me 1. So my choices basically are 1, 8, and 2. And so I would have to make the common base, I could do 8. Again, I could do 2. I could do 2 to the 3x equals 2 to the 0. But once that, I got to figure out 8 to what power is going to give me 1. What power of 4 gives you 8? Yeah, so no, I couldn't do 4. Yes, no. Still look like you don't believe me. Gotta have, I mean, you have to figure out what's, anything to the 0 power is going to give you 1. So that's where that one comes from. Okay, we good? All right, so before we talk about change of base, I just want you to look at number 19. If I do this the same way and I set this equal to x, and then I do 5 to the x power equals 34, is there any power, like could I get a common base of 5? No. Okay, so in this case, they don't all work out that way. If they do, then I need to be able to work them out without a calculator, because those would be all in the non-calculator section. And then, but some logarithms are not as easy to evaluate as those above, and will require the change of base formula. So we're basically going to change them all to base 10, and in order to do that, we use the change of base formula. We're just going to find the log base 10 of A and the log base 10 of B, make a fraction out of it, but you got to make sure you put the right pieces in the right place in the fraction. It's really pretty easy to figure out because B is the base and it's on the bottom, so when you come over here, is going to be log of A over log of B. It's still the base, it's still on the bottom. Okay? So number 19 is going to give me log of 34 over log of 5. Then in the calculator, I highly suggest that you hit the fraction button, type in the log of 34, you have to close the parentheses, arrow down, and then log of 5, close your parentheses. We should get 2.191. That's your answer. You have to get your number. Okay, so then on number 20, okay, I'm just going to do this one with you because I want to show you something in the calculator. Log of 98 over the log of 2. Now in your calculator, instead of retyping everything, arrow to the left, and then go up to the top and delete out the 34, type in 98. Arrow down, delete out the 5, type in 2, hit equals. You don't have to retype it every time. Okay, just go back and change what you had. 6.615. Okay? All right, y'all do 21 through 24. And yes, you have to write them out, and then you also have to find them. Okay, what's your question?
So on this one, on number 21,
Uh-huh.
the log of 4 over the log of 20.
Uh-huh.
18 is fine with the log of 5.
No, it would not be. There will be ways for us to condense and expand, and we will look at those, but that is not how it happens. Somebody told me they went and bought buy one of these calculators this weekend, and I think they said at Walmart it had gone up to $18, but it's still cheaper on Amazon, so they got it on Amazon. So I just thought I'd throw that out there. All right, so let's see what we've got here. All right, Jose, give me number 21. 0.46, what? 3? Okay, y'all agree with that? Yes? Awesome. All right, thank you. Nina, give me 22. Okay, 0.387, y'all agree with that? Yes, okay, thank you. 23, Jenny. Okay, y'all agree with that? Yes. Okay, and then Sakina, what'd you get for 24? -1/3. Y'all agree with that? Okay, very good. Thank you. Now look at 24 compared to the other 5 in this little group.
It's rational.
It's rational. Very good. It's rational. Way to use your fancy words, all right? It's a fraction, so it's a rational number. The rest of these aren't because we can't represent them as a fraction. So what that tells me is I didn't need to use the change of base formula, okay? So I just want to make sure that you understand this because this could show up on a non-calculator question. If I set that equal to x, then I would have x to the, I would have 8 to the x power equals 1/2. Okay, I would think most of you would probably use 2 as your base, yes? Okay, so if I use 2 as my base, then the exponent over here on this 1/2 has to become what? -1. And this is going to be 2 to the what times x? 3x power. All right, so now we have common bases, and now 3x equals -1, and that's why x equals -1/3. Okay? We just can't do that with the other ones because of the natures of the numbers, so that's why they come out and they're not rational numbers. Okay? All right, so there are your common logs and your change of base, and we're going to do a lot more stuff to manipulate logs. But let's talk about natural logs real quick. So base E, natural log. So log base e of x is the same as the natural log of x. Okay? And that is a lowercase l and an n, right? So if it says write each in exponential form. The natural log of x equals 4. So what's the base of that log? E. So if I'm going to write it in exponential form, e is my base. E to the 4th power would equal x. Here, e to the x power equals 10. And all we had to do was write it. We didn't have to find anything. No. Yeah, log base e is a natural log. That's what that means. It's the log base e. So natural log of x, I didn't just substitute in e right here. Well, it's not assumed, but yes. Yes. Assuming means you're not really sure, but whatever. Just saying.
That's not what it means. Just because it's not written there, they choose.
Well, if I can assume, but every time you assume something, are you right? No.
But possibly you are.
Okay, but here it's not possibly you are. You are right if it's e. Whatever. It's it's not assuming. Yeah, whatever. Okay. Right, so now I'm going to take the exponential and I'm going to write it in logarithmic form. So I have e to the x power equals 50. So my base is e. So I could do log base e, but that's not really how you do it. When it is log base e, you do natural log. So we do natural log of what? 50 equals x. And then here this would be the natural log of x equals 0.5. Okay, and here it just said write it. It didn't say solve it, it didn't say evaluate, it just said write it. Okay. Then it says approximate the value of each expression. So all we have to do is just type it in the calculator, actually. Find the natural log button. Or I lost my calculator, or I lost my... Yeah. So when you just do natural log of 64, you're going to get 4.159. And I just want to show you that, isn't log base 6, or natural log of 64 the same thing as log base e of 64? Isn't that the same thing? Okay, you don't write it like that, but it's the same thing. So if you had that, and let's say you didn't have a natural log button, which you would, but you could do the change of base. And if you did the log of 64 over the log of e, you're going to get the same answer. It doesn't really matter either way. You tell me. And then find the natural log of 1/3. To get negative 1.099. All right, Michael, tell me what you get when you do that. Because you just have to, and if it's in a fraction. Oh, look at that. It's the same thing. Because what's the natural log of e? Well, wait until I'm going to go over a couple of these. You might want to listen to them. What's the natural log of e? No, that's what e is. What's the natural log of e? Quit yelling things out. You have a calculator in front of you if you don't know.
Oh, yeah.
Look, the natural log of e, if I say the natural log of e equals x, right? So what's the base here? E. So if I rewrite it exponential, I'm going to get e to the x power equals e to the first, so x equals 1. So the natural log of e is 1. Okay? There you go. That's fine. All right, so let's look at your homework real quick. Want you to look down. So on the top, make sure you're reading the directions, because on 1 through 12, it just says write them. It doesn't say to evaluate them. You just got to rewrite the forms. When you get down to 13, it says evaluate each logarithm, use the change of base formula when necessary. So I better not see the change of base on every single problem, or I'm going to count them wrong. You only do it on the ones you have to do it on. If you look at number 13, if I set this equal to x, then this is going to give me 3 to the x power equals 81. Can I do this one using common bases? Yes, my common base would be 3, so 3 to the x equals 3 to the what? 3 times 3 is 9, times 3 is 27, times 3 is 81. So the fourth. So x equals 4. See, didn't need to change the base. Didn't need a calculator because you have to be able to do them without and with, basically. So now jump to 19. If I set this equal to x, and I do 18 to the x power equals 124, well, this doesn't break down to a nice, base other than 18. And 18 to the first is 18. 18 squared is way bigger than that, right? So am I going to be able to get a common base here? No. So then on this one, you would want to use the change of base. So I would want to do the log of 124 over the log of 18. Okay, that one, it makes sense to do that one. Number 13, it does not. Okay, so then when we do that, we get 124 over the log of 18. Then what? Evaluate each logarithm. Do you need to do change of base or anything with it? Yeah, 0.668. Okay, we good on that? What questions do you have? We good? All right, good deal.